Now, is there any possibility for stable carbocation formation? Right? So this bond cleavage happens to form more stable carbocation. Over that more stable carbocation, I minus will go and attack. It forms methanol plus CH3, C positive charge, CH3, CH. This will combine with I minus to form alkyl iodide. That I minus will come over this either above the plane or below the plane because this is sp2 hybridized, right? So reaction is proceeding via what mechanism? SN1, more stable carbocation formation. Clear? Now I am taking one more example. If there is no such more stable carbocation formation, if this is allowed to react with HI, first step is as it is. Salt formation. Is it salt formation or not? Now, is there any more stable carbocation? Whether this bond cleaves this side or that side. This side it forms ethyl cation, that side it will get methyl cation. Both are primary. Primary carbocations are unstable. Therefore, reaction should proceed via SN2 mechanism. In SN2 mechanism, I minus has to go and attack. Where it will attack readily? Or ethyl or methyl? Methyl, because crowding. And in SN2 mechanism, less crowding is preferable. Right? So compared to this side, I minus will go and attack over this system. So reaction will proceed via SN2 mechanism. So product will be ethyl alcohol plus methyl iodide. Any questions are in this online? You have any questions in this?
No, sir.
No, sir.
Our screen is visible to you.
Yes, sir.
Yes, sir.
For me, it is not visible. They changed the settings or something like that. I don't know. I will rejoin again. Now I am taking one more example, sir. Methyl propyl ether. Now it is allowed to react with HI. Another one allowed to react with excess of HI. What happens first? Above and this, both cases, first H plus will go and attack. On both sides, are you able to get any more stable carbocation? Say something, whether you get more stable carbocation or not. Because both sides you will get primary cations only. Right? Both are unstable. So reaction should proceed via SN2. Right? Either here or here. Both cases SN2 only. So what should be the product? Where iodine comes, where you will get alcohol. Methyl iodide and you will get propanol. If it is excess of HI, again this propanol reacts with HI to form. Alcohol will react with HI again, to form. That also alcohol also converts into iodide. So if it is excess HI, product will be methyl iodide plus propyl. So both will convert into iodides. One more example I am taking. Cyclic system. Cyclic ether allowed to react with one equivalent of HI. HI, one equivalent. Now tell the product, sir. First H plus will go and attack over oxygen. You will get OH, positive charge. Then on which direction cleavage should happen? Above or below? Above. If it cleaves this bond, if this bond cleaves, what happens? More stable carbocation will occur. Over that, I minus will come. So product will be 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Here you will have OH. Here you will get iodine. Acceptable, sir? 1, 2, 3, 4, 5.
Sir,
Yes, sir.
sir, can I explain, sir? Again.
First H plus will go and attack now. You will get OH. You got positive charge here. Now, if this cleavage occurs like this, then you will get more stable carbocation, not tertiary.
Yes, sir.
That means I minus now will go and attack over that. Correct? Huh?
Yes, sir.
Sir,
Take one more example. We are taking any sol. With one equivalent of HI. And also with the excess of HI. Tell the products or no? Any sol with HI one equivalent with HI excess. What should be the product? First step H plus will go and attack. In both cases, that is common, right? So in both cases, intermediate remains same. This is the intermediate in both cases. Now this intermediate should convert into product. Now tell me what should be the product. Which direction I need to cleave the bond? Towards benzene here. If I break this bond, you will get positive charge over benzene. The carbocation positive charge, benzene means phenyl cations are highly unstable, impossible. For unsaturated bond, positive charge is impossible. So this will not occur. Then reaction should proceed via SN2. Now I minus should attack over methyl. Correct? Huh? Is there any other choice? So what should be the product? Phenol plus methyl iodide. If I take excess, then also same. Phenol will not react with HI. Correct? Huh? So in both cases, I will get same product. Because phenol cannot react with HI. Are half that, man? Next, sir. G's method or G cell method. Go and get remote, switch it off. So what a G cells method means? Number of ether linkages exist in polyether. If you are able to identify, we call that method as G cells method. So this method is used to identify number of alkoxy groups. For example, CH2OCH3, CHOCH3, CH2OCH3. If it is allowed to react with excess of HI, what do you get? If this is allowed to react with 3 equivalents of HI, what you should get? Isopropyl, iodide, be cautious. Whether it is the excess of HI or 3 equivalents of HI. Observe this reaction. I am taking 3 equivalents of HI, sir. What happens now? You will get OH here, OH here, OH here. Then methyl iodide. Here also methyl iodide, here also methyl iodide, and this will convert into glycerol. So you will get glycerol plus 3 equivalents of methyl iodide. Now this methyl iodide is allowed to react with AgNO3. Number of moles of AgI formed. Will conforms number of iodides allowed to react or number of alkoxy groups. Correct or not? If you have one alkoxy group, you will get one CH3I. If it is one CH3I, you will get one AgI. If you have 3 alkoxy groups with the excess of AgNO3, you will get 3 AgI. Number of AgI molecules obtained from given ether conforms number of alkoxy groups. Correct or not? This is called as G's method, G cell method. Instead of this, if it is allowed to react with excess of HI, then what happens? What happened now? This glycerol also converts into iodides. If 2 adjacent carbons have iodine, I2 will be eliminated to form a double bond. Double bond reacts with HI again to form iodine here. Again, I2 is eliminated. So final product will be isopropyl iodide plus 3 moles of methyl iodide. Observe the difference, sir. With the 3 equivalents of HI with the excess of HI. Respond. Any questions here? Online, someone respond.
No doubts, sir.
Sir,
Yes, sir.
sir, here we know the number of methyl groups, so we use the 3 equivalent. If you don't know means.
If you don't know, by you adding excess of AgNO3, number of moles of AgI we will calculate. Based upon number of moles of AgI, we are going to predict number of alkoxy groups present.
Okay.
Done. One more example. O methyl, again O, again phenyl, O ethyl, and here O methyl. This is allowed to react with excess of K8. Now tell me, sir, product. What can be the product now? First, this will break. This will convert into ethyl iodide. Phenol will never react. So you will get OH only. Here, methyl iodide. Again here, phenol doesn't react. Here also it will break. Here also methyl iodide. Here also OCH3 is there, no? Correct or not? So product will be 2 moles of methyl iodide plus 1 mole of ethyl iodide. What about this one? Either present between 2 benzene rings. And if OH comes here, bond will not break that side as well as this side, na? Because on benzene ring, positive charge is impossible. So it will never happen. And SN2 fails. Means that link remains as it is. That will cannot be disturbed. So you have OH here, O. You have OH here and OH here. Acceptable, sir? Say something. Correct or not?
Yes, sir.
Next. CH3, CO, CH3, CH3, CH3. If this is allowed to react with, instead of HI, I am taking concentrated sulfuric acid. Now what happens, sir? Now what happens? Again, H plus will go here. You will get OH. It can break. You will get methanol. After methanol, you get tertiary carbocation. After getting tertiary carbocation in presence of strong acid, on heating, what should happen? Elimination. So what you should get? Plus methanol. Acceptable? Correct or not? Reaction proceed by R. Even elimination. Correct or not? This is methanol. You got tertiary carbocation. Tertiary carbocation means even mechanism, no? Next one. Third reaction, sir. This is about second reaction. Breaking ether linkage in presence of acids. Next, third reaction. Reaction with PCl5 or SOCl2.
Sir.
Yes, sir.
So in the previous example, you have told carbocation, tertiary carbocation will undergo E1, no, sir?
Correct.
Sir, but when reacting with HI, we are not able to get elimination, no, sir?
No,
Due to the presence of iodine, sir.
Tertiary carbocation, as you are taking I minus, right? I minus will go and attack over carbocation to form alkyl iodide. Correct?
Yes, sir.
Now in this case, HSO4 minus will go and pull this acidic hydrogen because you are heating strongly, right?
Yes.
Alcohols in presence of strong acids prefer elimination mechanism or not?
Yes, sir.
H2SO4 is a dehydrating agent or not?
Yes, sir.
So that's why elimination I have done.
Okay, sir.
Clear? Next, reaction with PCl5 or SOCl2. What happened? You will get generally alcohols. Alcohols with PCl5 forms alkyl chlorides. So ethers also form respect to alkyl chlorides. So example, ROR with PCl5 on heating. Now tell the product, sir. This R and that R both will convert into alkyl halide. Correct? First oxygen will donate lone pair of electrons. See, reaction occurs in this way. First oxygen will donate lone pair of electrons to phosphorus. And from phosphorus, chlorine will be replaced. Because phosphorus have empty orbital. No? So I am taking that PCl5 like this. Now alcohol will donate lone pair, making any chlorine, either this or this, any one chlorine has to be gone. So I am writing P, Cl, 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 and Cl. 4 Cls and 1 Cl minus already came out. Right? Then what happened? This bond shifts here, this bond shifts here. Then product will be R, O, double bond P, oxygen gets positive charge, chlorine, chlorine, chlorine. This converts into RCl. Response are. Now, this is Cl minus will now go and attack over this R, making this to shift. So, final product will be PoCl3. This converted into RCl. This is already RCl. So, product will be 2RCl plus PoCl3. Same thing we have studied in case of alcohols also. Now, same way with SOCl2. ROR with SOCl2. Compared to PCl5, SOCl2 is preferred. Reason? SO2 gas escapes, reaction always moves in forward direction. So 2RCl plus SO2 gas. Now an example. One cyclohexyl ring, one cyclopentane ring. Right? So what we call this as? Cyclopentyl, cyclohexyl either. Now this is allowed to react with PCl5. Now what should be the product? If this is allowed to react with SOCl2, what should be the product? What can be the product? In both cases, same. What you will get? Cyclohexyl chloride, cyclopentyl chloride. There PoCl3, here SO2. Any questions? Next slide. Oxidation of ether by air or ozone. Here I will write. Oxidation of ether by air or ozone. Means if ether was exposed to atmospheric air, slowly that oxygen will react with ether to form peroxyethers. Right? Corresponding example. ROC2H5. Or I am writing CH2R. With atmospheric oxygen in presence of sunlight forms peroxyethers. ROC2 O CHR OOH. Peroxy ethers, right? This thing already we have studied somewhere. Peroxy rearrangement, Hawk rearrangement, right? Phenol, cumin with atmospheric oxygen, same type of mechanism, right? So this is peroxy ethers or ether peroxide. And it readily decomposes to produce nascent oxygens. So it is a very good oxidizing agent. So reactions where peroxy ethers are present, they react violently. They are highly unstable. That's why whenever you are taking ethers as a solvent, first we need to check, is there any peroxy ether linkage present or not? If there is peroxy ether linkage, we should not use that ether as a solvent, because this will interfere in the reaction, right? Note. If peroxide is present, they react violently. And hence, we need to check whether that peroxy linkage is present or we need to remove it. For example, we are taking peroxy ether. Ether is mixed with Ki aqueous. Actually, ether is colorless, Ki is also colorless, right? But if peroxy bond is present, peroxides will oxidize I minus to I2, right? If peroxy bond is present, if a peroxy bond is present, I minus will convert to I2. I2 with Ki forms Ki3. K plus I3 minus complex Ki3, which is yellow in color. Are you able to understand? So when ether is mixed with the aqueous Ki, if you are able to see yellow color, means peroxide is present. If you are seeing it as a colorless, means peroxide is absent. Any questions, sir, in this? Is there any questions in it? Same way, one more reaction. Ether is allowed to react with ferrous sulfate. And then I am adding potassium thiocyanate, KSCN. No. If peroxide Fe plus 2 is oxidized to Fe plus 3. Fe plus 3 with thiocyanide ions forms FeSCN complex. It shows blood red coloration or not? Responses. Right? So if you are able to get blood red coloration, confirms peroxy. if you are not able to get blood-red coloration, absence of oxide. Is it clear? So this is the test for peroxide. Next one, halogenation. So fifth reaction, sir. Online, any questions, sir?
No, sir.
Ethers with the chlorine in darkness, reactions will be slow. If they are allowed to react with the chlorine in presence of light, radical chain mechanism. If it is a radical chain mechanism, means what I have to do? Reaction should proceed till all hydrogens are replaced by chlorine. Correct or not? Right? So if it is chlorine in presence of dark, reaction will be slow. So one of the hydrogen is replaced by chlorine. If it reacts further, then another hydrogen is replaced by chlorine. If it again allowed to react, slowly one by one chlorine will be replaced. But if it is done in terms of light chain mechanism, all hydrogens are replaced by chlorine. So can I write as C2Cl5 this side? So I am writing it as C2Cl5 bond O bond C2Cl5. Any questions? Next reaction. Reaction of ethers with acetyl chlorides. Or acetic anhydrides. Or with Al2O3 on heating at 300 degrees centigrade. Or with carbon monoxide. Example C. ROR ethers allowed to react with acid chloride first. With the CH3COCl in presence of ZnCl2 on heating. Now what happens? Either can donate lone pair of electrons to carbonyl system. I am writing it as ROR. This is R prime COCl. This can donate lone pair of electrons or not. If it donated lone pair of electrons, this bond will be shifted here. So product will be R prime C O minus Cl bond O R one lone pair positive charge. Right? Now this will come back, making this Cl2 leave. Possible or not? Right? So while that Cl is leaving, I am trying to rearrange like this. What you will get now? What you are getting? R prime C double bond O R plus RCl. Correct? So in this ether, OR is replacing chlorine. Chlorine comes over another R. So what you are getting? Ester. So product will be R prime COOR plus RCl, ester formation. Any questions are in this? Clear or not? Right. Now, same way with acid anhydride. R prime, CO, O, again CO, R prime. Now what happened? Either will go and attack, this will shift, comes back. So it will convert into R prime, C double bond O, O, R. Again, what is left? Again, R prime, CO, O minus left, na? That will combine with again R plus to form again ester. Correct or not? This part will, this is one SI. This is O8. That O8 will go to R and this SI will go to OR. So product will be 2 moles of R prime, CO, O, R. Any questions, sir, in this? Respond. Any questions in this?
No, sir.
No, sir.
No. With Al2O3 on heating, that too at 300 degrees centigrade. Already we discussed this reaction. Ethers with Al2O3 or alcohols with Al2O3 at 250 degrees centigrade form ethers. See here. Alcohols with Al2O3 at 250 degrees centigrade form ethers. Instead of 250, if it is a 300, you will get alkenes. Are you able to understand? Alcohols with Al2O3 up to 250, you got ether. If it is a 300, instead of ether, you will get alkenes. So I am writing the same here. At 300 degrees centigrade, what I should get? Alkene. No. If it is acid hydrolysis, H plus and H2O. What happened now? H plus will go and attack over it. You will get OH, positive charge. Then H2O will donate lone pair of electrons to any one R, wherever crowding is less. Then both will convert into alcohols, correct? This is R bond O, R. First H plus will come here, you will get positive charge. Then H2O can donate lone pair of electrons to anyone. Then what happened? This will convert into alcohol, that also convert into alcohol. So product will be 2 moles of ROH. Any questions, sir? Respond. Do you have any questions in this?
No, sir.
Next, sir. Ethers with carbon monoxide. take it as a note. Ethers with carbon monoxide at special conditions in presence of catalyst form esters. We call it as carbonylation reaction. Example, diethyl ether with the carbon monoxide in presence of catalyst like boron trifluoride, pressure of approximately 500 atmosphere, temperature approximately 150 degrees centigrade. Then this CO, oxygen have lone pair of electrons. This will donate lone pair of electrons to CO. So product will be, I am writing like this, O, ethyl, oxygen will donate lone pair of electrons to CO. This is C triple bond O, right? Say something. And carbon monoxide, man. You will get positive charge here, you have lone pair and negative charge here, correct? Now, this oxygen will donate lone pair of electrons. If it donate lone pair of electrons, what happens? This bond will shift. So product will be ethyl bond O, ethyl. Now you have positive charge over this. Single bond C, double bond O, oxygen's lone pair got restored, and here it remains as negative. Now what happens? This will shift here. Then what happens to this ethyl? Ethyl becomes positive, and this carbon is negative. Therefore, that ethyl comes here. So product will be ethyl O, C, double bond O, ethyl. So what do you want? Ester or not? Ethyl COO, ethyl. So product will be ester formation. Yes, sir. Which one? This one. Fully zoom. What do you want? Arey, you come here, man. All benches are free. I told you in day one class only. I will not increase the size. Reason is you are sitting in the last benches by leaving all the front benches empty. Right? You have to come to front benches. Right. So reaction with acid halides, acid anhydride, Al2O3 on heating is over. And a reaction with carbon monoxide is over. Reaction with epoxy is already over. Now, reaction of aryl ethers, right? Next reaction, sir. Seventh reaction. Reaction with aryl ethers. Means benzene ring is present in ether linkage, right? When benzene ring is present with oxygen, oxygen acts as plus M group. Response, sir. For example, if I am taking like this, what is this one? Is it anisole? This acts as plus M group. It will increase electron density over benzene ring. So it behaves as ortho para-directing. Correct? So electrophiles prefer to go to either ortho position or para position. What we call that as electrophilic aromatic substitution reactions. So here it will prefer electrophilic aromatic substitution reactions. Electrophilic aromatic substitution reactions. So in ethers, oxygen will try to donate lone pair of electrons into ring. To show resonance. So this will shift here. This pi bond will be shifted here. You will get different resonating structures. In that, you will get a double bond O, CH3. You will get positive charge here. And you get negative charge here. Acceptable, sir? Now again, this will be shifted here. This pi bond will be shifted here. O, CH3. Now you got double bond here. You got negative charge here. Again, this will be repeated. Double bond O, CH3. You got negative charge here. Now again resonating form. This will shift and this will go back. Lone pair got restored. So overall you got negative charge at what positions? At ortho, meta, again ortho. Correct? Huh? So this behaves as ortho para directing group. Or we also call it as ring activating group. Ring activating or ortho para directing. Right. So allowed to react with bromine in presence of acetic acid. Bromine in presence of polar protic solvent or not acetic acid? Response, sir. Phenol in presence of bromine water, what you will get? Phenol with bromine in presence of water. 2,4,6 tribromophenol, white PP. Correct? If it is bromine and CS2 carbon disulfide, ortho or para. Para becomes major. Same way if it is either with acetic acid, I should not use strong acid. If I use strong acid, what happens? Either linkage will break. That's why I'm using weak acid. So here also I will get ortho as well as para. Ortho bromo or para. Which will be major? Which will be major? Generally, in all cases, which will be major, sir?
Para, sir.
Unless is there any hydrogen bonding yet ortho position, intramolecular hydrogen bonding. If there is possibility of intramolecular hydrogen bonding, then only ortho becomes major. Otherwise, in all cases, para will be major. Acceptable, sir? Next one. CH3Cl in presence of AlCl3. Can I call it as Friedel-Crafts alkylation? Friedel-Crafts reactions fail in presence of withdrawing group. But what type of group it is? Donating group. Right? That's why product will be again same. CH3 group will be either at ortho position or para position, which will be major. Again, para becomes major. Friedel-Crafts alkylation reaction. This do not occur if withdrawing groups are present. Correct? Huh? This do not occur with nitrobenzene. In case of nitrobenzene, Friedel-Crafts reaction fails because NO2 is a withdrawing group. So can I use nitrobenzene as a solvent now? Because it will not react, so it is inert. Therefore, it can be used as solvent. Because of this, this can be used as solvent in Friedel-Crafts reaction. Any questions? Next, acylation. This is alkylation. Now we are talking about acylation. CH3COCl in presence of AlCl3 or ZnCl2 or FeCl3. Now same. OCH3 at ortho position COCH3 or at para position COCH3. This is Friedel-Crafts acylation. Here, what is the intermediate? Acyl cation is the intermediate. Correct, sir? And shows resonance. Respond. This oxygen can donate 1 pair of electrons back to this to form triple bond. Satisfied octet. That's why it is more stable. So acyl cation is the intermediate. The above case, methyl cation is the intermediate. Next, nitration.
Sir, in acylation, para group will be major. Sir, but intermolecular hydrogen bonding will not be there, sir.
Where is hydrogen, man? Hydrogen should be present on more electronegative atom. Where is hydrogen on more electronegative atom? So there is no intramolecular hydrogen bond. Clear?
Yes, sir.
Now I am taking concentrated HNO3 in presence of concentrated H2SO4. What is this reaction? Nitration. So product will be orthonitro or paranitro. Which is major? Again, same. Paranitro will be major. Same way in case of phenol, sir, what you will get? If a phenol allowed to react with nitration mixture, picric acid becomes minor product. Quinone becomes major product. Phenol. Huh? And see? Above reaction. During nitration, concentrated HNO3 and H2SO4, which became major. Quinone becomes major. 2,4,6-trinitrophenol becomes minor. If it is purely concentrated HNO3, then picric acid is major. If it is a dilute HNO3, then orthonitrophenol becomes major because of intramolecular hydrogen bond. Clear? Any questions, sir, in this? Online, someone respond.
No, sir.
No doubt, sir.
Next, sir, uses. That ends alcohols, phenols, ethers chapter. Used as a solvent, particularly diethyl ether. In case of oil industry, for fats during manufacturing of waxes, plastics, lacquers, etc. Used as a inert medium, particularly in reactions like Wurtz reaction. That's what in Wurtz reaction, sodium in presence of dry ether, right? Used as inert medium. In Wurtz reaction, wherever I am using Grignard reagent, correct or not? While you are using Grignard reagent, there also you will take dry ether as a solvent, right? Etc. Next, anesthetics. Etherne. Fluorine, chlorine, CF2, O, CHF2. This is etherne. Isoflurane, CF3, CHCl, OCHF2. Isoflurane. Halothane, CF3, CHCl, Br. These are used as inhalation anesthetic materials.
Sir,
Yes, sir.
should we remember the structures of these?
No need. As a theory only. As they are inert, ethers are less reactive, no? That's why they are inert, and hence they will not give any irritation over lungs. Right, here I missed O, I think. Right, halothane, no? Halothane is only organo alkyl halide. These are all ethers. This is only haloalkane derivative. Inhalation anesthetic without affecting lungs and heart. Next, used in petrol, refrigerant, smokeless powders, perfumes. So we are done with alcohol, phenol, ethers topic. Right, sir? Any questions?
No, sir.
This mechanism also done. These reactions also done. Dry ether is done. You cannot get positive charge over that. Therefore, both are iodides. Phenol's already over. Glycine reaction is over. All these things are over. We are done with this, sir. Next chapter, sir. Aldehydes, ketones, and carboxylic acids. I think last chapter of JEE mains question. Amines are okay. I need to teach amines again, huh? Okay, amines I will teach again.
Sir, biomolecules.
Over, man, biomolecules. Hey, biomolecules over or not? Over, sir, biomolecules. Right. So next heading, sir. Aldehydes and ketones. As usual, first thing is IUPAC nomenclature and the types, different types of functional groups possible with that, right? So first regarding reintroduction, sir. Symmetrical, unsymmetrical ketones, and one is aldehyde. So coming to this one, if I take RCHO, we call this function group as aldehyde group. Therefore, in IUPAC, we will write AL. Correct? All. If it is present between two carbon systems, then we call this as keto group. Then we will use the function group as suffix as "-one". Most of the fragrant materials, smelling materials in nature, naturally, they may be either aldehyde forms or keto forms, or maybe acid derivatives, means ester forms, right? Example, vanilla. It is obtained from vanilla beans. Salicylaldehyde, cinnamaldehyde. If it is aldehyde and OH group, it is salicylaldehyde. If it is aldehyde and if it is carboxylic acid and OH, salicylic acid, right? So this is salicylaldehyde. Yes, yes, yes. Carry on. On benzene ring, if you have CH double bond CH2, then what do we call it as? What do we call it as? Styrene. Over that, if you have aldehyde group, cinnamaldehyde. Yes, sir. right? So I prefer chromic anhydride. Chromic anhydride means a dehydrating agent. Chromic anhydride dehydrating agent means Cr2O3 means this will alcohol will convert to acid. This will not react. This converts into ketone. This will not react. This will not react because this is you are taking chromic anhydride means oxidizing agent. Oxidizing agent will convert primary alcohols to carboxylic acid. Secondary alcohols to ketone. Tertiary alcohols will not react. Phenols do not react. Means these two groups remains as it is. These two will oxidize. So they are no longer alcohols now. So P gives steric ammonium nitrate test means this is because of tertiary OH group and this OH group. So these two groups remains as it is. So answer should be with respect to B and D. Check the answer. But actually steric ammonium nitrate should be because of B only. But in the product B and D both are present. Check.
Force B and D.
B and D.
Sir, your screen is not visible, sir.
I have not yet started. Are you join in the next link now? All of you join in the next link. Yes, madam. Online to the screen is visible to you all. Someone respond, please.
Yes, sir.
Yes, sir.
Yes, sir.
Where we have seen this one. Are any of you wants to check ceric ammonium nitrate, whether two NO3 groups are replaced or one NO3 group is replaced? Because this is one previous question. I've written this somewhere, but I am not able to find it now. I think maybe in your target booklet it will be found. Reaction of alcohols with CAN, ceric ammonium nitrate, maybe in addition information.
Sorry, one NO3 group is replaced.
Only one NO3 group is replaced. Huh?
Yes, sir. Page 33.
CeNO3 6 times, right?
Yes, sir. That is replaced with CeOR NO3 5 times.
5 times. Not this one. See this one, sir. In alcohols, note this another important reaction. Take it as a note. Ceric ammonium nitrate, sir, also called as CAN. Ceric ammonium nitrate. This is also a good oxidizing agent. It is used to test phenols, alcohols, and amines. They will give color with ceric ammonium nitrate. This is the complex CeNO3 6 times. Here it is in +2 state, sorry, -2 state, so which is balanced by NiH4 twice. So this is a ceric ammonium nitrate, octahedral complex. If it is allowed to react with alcohols, removal of H is also oxidation, right? So the product will be NiH4 twice Ce or, are you able to understand? Right? Alcohol got oxidized to aldehyde. Respond. Or maybe RO minus. Then it acts as a good base, nucleophile, right? Or ligand. So then it will be NO3 5 times. This is the complex generated. That H plus means indirectly here H plus is gone. That H plus combines with one of the NO3 to form HNO3. Means indirectly NO3 minus is replaced by aldehyde group. Correct or not? So this is red in color. This is the confirmation test for alcohols, phenols either. So particularly phenols and tertiary alcohols give positive test here, right? See this statement, just listen to this statement. Ceric 4 ammonium nitrate is a 1 electron oxidizing agent. A 1 electron oxidizing agent means it will gain only 1 electron. That means here H plus will be gone. Now R minus is there. 1 electron belongs to oxygen, another electron will be taken by cerium, right? So 1 electron oxidizing agent that is used for oxidative addition reaction of electrophilic radicals to alkenes, enabling intermolecular and intramolecular carbon-carbon and carbon heteroatom bond formation. CAN is also oxidizes secondary alcohols to ketones, benzyl alcohols to aldehydes. The oxidation of TEMPO and CAN can be used for aerobic oxidation of benzyl and allyl alcohols into corresponding carbonyl compounds. However, steric hindrance, okay, that is as usual. Sulfides to sulfoxides, this is also known only. That's all. So here we can write one more point. CAN can oxidize. Oxidizes secondary alcohols to ketones. Whereas benzyl alcohols to aldehydes. Any questions in this? Right, now I am coming back. So that question is done. Right, sir. We are discussing about introduction of aldehydes and ketones. In nature, most of the natural products are having either aldehyde group or keto group. So that's why I'm making one statement here. Aldehydes and ketones are widespread in plant and animal kingdom. Next, classification. Aliphatic aldehydes. I will complete IUPAC nomenclature here itself, sir. We will not discuss nomenclature again. So we are discussing about aliphatic aldehydes. Formalin. What is formalin, sir? Formaldehyde. Also called as methanol. Acetaldehyde means CH3C. 2 carbons must be there. Also called as methanol. Or we also call it as formalin. But in case of formalin, we use this formalin in order to store species, biological species, right? So they are saying 37 to 40% formaldehyde by weight, along with a stabilizer like methanol. So methanol plus formaldehyde mixture is called formalin solution, right? So we are writing formalin solution. Methanol plus methanol. We will understand now. OL plus AL, right? This is approximately 37 to 40% by weight. Used for preservation of biological species. Powerful disinfectant. Next one, acetaldehyde. IUPAC name, ethanol, NaL. CH3, CH2, CH2, CHO. What is this one? Butanol. And I always start numbering from functional group, carbon present inside the functional group. Aldehyde groups always exist at any one terminal, right? If it comes into the center, we call it as keto group. Next. Aromatic aldehydes. Example, benzaldehyde. What is the name of this one, sir? Cyclohexane carbonyl, carbaldehyde. Cyclohexane carbaldehyde. Because when you are naming cyclohexane, you are not counting that carbon into principal chain. That's why we need to mention that carbaldehyde separate. Next, aliphatic ketones. There will be two types: symmetrical, unsymmetrical. So we call this as acetone nail polish remover, correct? Huh? Used as a good solvent. IUPAC name: propane 2-one or 2-propanone, correct? Huh? Response, sir. Next, aromatic ketones. What is the common name of it? What it is called? Acetophenone. Acetophenone. IUPAC name? IUPAC name? Acetyl benzene. Acetyl group, benzene group, man. Right? Respond. No. What about this one? On benzene ring, if it is CO, again benzene ring, then this is called benzophenone. Now, some names: CH3, CH, double bond, CH, CHO. Is it allyl aldehyde or not? If there is no CH3 group, then it is called acryl aldehyde, or we call it as acrolein. Now it is called croton aldehyde. Croton. What it is? Money plant, huh? Or you call it as money plant or no? Right? Yes or no? Right? Croton aldehyde. This is called acryl aldehyde. Or we also call it as acrolein. CH3, CH3 double bond, CHCOCH3. It is called mesitile oxide, cat urine smell. That smell of cat urine is because of this one, right? Mesitile oxide. Or having mesitile oxide is having the smell of, okay. Then methods of preparation of aldehydes and ketones. Next heading, sir. If you have again this one on the other side, then it is called 4-one. Just a moment. Mesitile oxide, no? After name some named reactions. Yes, yeah. This is called 4-one. CH3, C double bond, CH3, CH, C double bond O, again CH, double bond C, CH3, CH. This is called 4-one. Right? Mesitile oxide, 4-one. These things you will study in aldol condensation reaction. Aldol condensation can be done in acidic medium as well as basic medium. When you are seeing aldol condensation in acidic medium, you will see these two compounds. In basic medium also, you will get same type of products, but mechanism changes a little. Next heading, sir. Preparation of aldehydes and ketones. In which first one? From alcohols. No need to discuss it. Already this is over, man. By using mild oxidizing agents, primary alcohols gives aldehydes, secondary alcohols gives ketones, tertiary alcohols do not react. If it is a strong oxidizing agent, so primary alcohols gives carboxylic acid, secondary alcohols gives ketones, tertiary alcohols, no reaction, right? So I'm writing the same statement. Primary alcohols with mild oxidizing agents. Give an example of mild oxidizing agents. CrO3.
Chromic oxide.
Presence of pyridine. Same CrO3 in presence of H plus, Jones reagent. CrO3 in presence of H2SO4, Jones reagent, strong oxidizing agent, right? So PCC or PDC or copper, all these are mild oxidizing agents. So form aldehydes. Similarly, secondary alcohols gives ketones. Tertiary alcohols, no reaction. Response, sir. H2CrO4, KMnO4 in presence of H plus, CrO3 in presence of H2SO4. All these are good oxidizing agents. Now, in this case, if it is primary alcohol, forms carboxylic acids. But if it is methanol forms, you will not get formic acid. Formic acid also will be oxidized to carbon dioxide. Yes. Clear? Remaining all primary alcohols gives corresponding acids, but methanol gives carbon dioxide. I think no need to discuss further. Now, in case of PCC, we've had one exception. PCC will not disturb carbon-carbon double bond, but it will show one type of reaction. What is it? Oxidative annulation. You will get cyclic compound. Here. PCC does not affect carbon-carbon double bonds in presence of alcohols. Note, in presence of PCC, oxidative annulation happens. Right? There will be bond formation between double bonded carbon and alcohol carbon. You will get a bond there by removing hydrogen and hydrogen. Removal of hydrogen is also called as oxidation. So you will remove hydrogen from. And again, you will remove hydrogen here and hydrogen here to form ketone. So oxidative annulation of alkenes happen in presence of PCC. PCC is a mild oxidizing agent. Right? Same PCC in presence of DMF or in presence of H2O oxidizes. Now,
Not visible, sir.
No, sir.
To return to your call, open Gmail. Close this. I will open this. Join from here. Now, sir.
Visible, sir.
Yes,
Right. So we are discussing about preparation of aldehydes and ketones from alcohols, in which by using mild oxidizing agents we can form. If I am using strong oxidizing agents, I can use for secondary alcohols, I can use strong oxidizing agents also. Next, catalytic oxidation of alcohols, or we also call it as a dehydrogenation of alcohols by using catalyst. So by catalytic dehydrogenation. So alcohols in presence of heavy metals, in presence of heavy metals like silver or copper on heating, then they will convert to aldehydes. There is no decrease in number of carbons. Number of carbons should remain same. But in case of secondary alcohols, you will get ketones, and tertiary alcohols, you will get alkenes. Now what you will get, sir? This is also primary alcohol, so it also will convert to aldehyde. This is tertiary alcohol, so this will convert to alkene. Next, from hydrocarbons. So preparation of aldehydes and ketones from alcohols part is over. Most of this reaction we have seen in alcohols chapter itself. So we are not extending this further. Response, sir. Regarding Tollens reagent, failing solution, Benedict also we have done, if you remember, right? So we are not discussing much. So next, preparation of alcohols from hydrocarbons. This also we are done. From hydrocarbons.
Sir, can I scroll up, sir?
So in which first one? Ozonolysis. Response, sir. Ozonolysis is done or not?
Yes, sir.
Alkenes or alkynes during ozonolysis, you will get. If it is reductive ozonolysis, you will get aldehydes or ketones. If it is oxidative ozonolysis, you may get acids. Of course, if it is formic acid, you will get carbon dioxide. Right? So reductive ozonolysis we are talking about. So directly we are taking one example. CH3, C, CH3, double bond, CH, methyl. This on reductive ozonolysis. Reductive ozonolysis means we will take O3 in presence of CH2Cl2 or CHCl3 or CCl4, any solvent, aprotic solvent. Response, sir. Followed by zinc. If a zinc is absent, what happens? Oxidative ozonolysis. In presence of zinc, it is reductive ozonolysis. Or you can use dimethyl sulfide. CH3, CH3. Either you can use zinc in presence of water or you can take dimethyl sulfide. So then we call it as reductive ozonolysis. What happens first? Ozone will go and attack over carbon-carbon double bond. First it will form ozonide. Later it will rearrange to malozonide. Then it will be converted to aldehyde or ketone. Correct, sir? First it will convert into correct or not? Later it will convert to correct, and then it will convert to aldehyde and ketone. So here also will you understand if I write like this? One oxygen goes to this carbon chain, another oxygen goes to that carbon chain, one more oxygen is left. That oxygen will be taken by zinc to form zinc oxide. If a zinc is not there, then what happens? That oxygen will combine with these aldehyde groups to form carboxylic acid. Then I call it as oxidative ozonolysis. Any questions, sir, in this?
No, sir.
Next one. Hydration of alkynes. Hydration can be done by two ways. What are they? Hydroboration oxidation, oxymercuration, demercuration, acid hydrolysis. Right? Three ways. Correct? So we are now seeing about oxymercuration, demercuration. By taking one example. CH3, C triple bond CH in presence of HgSO4 1%, H2SO4 40%, followed by reaction with after mercuric sulfate in presence of acid. This is one reaction. Next, what we will do? Sodium borohydride in presence of water. Correct or not? So when you add this one, what happens first? Hg plus 2 form 3-membered cyclic transition state. Correct or not? So product will be CH3C double bond CH Hg. Correct? You get a cyclic transition state. 3-membered. If it is mercuric acetate, you write 1 plus and you write OAC. Then with the sodium borohydride in presence of water. Then you will get CH3, C, OH, double bond, CH2. Reaction proceed via Marconi or anti-Marconi? Marconi-Koch product. So by removing one pi bond, we added H and OH. OH have gone to more substituted carbon. That's why Marconi-Koch product. Now it undergo tautomerism or not? Now it undergo tautomerization. Now what happened during tautomerization? Converts into ketone. Done, sir? Next, by using Walker's process. What is Walker's catalyst? PDCl2. PDCl2 is called Walker's catalyst. By using PDCl2, if I do coupling, then it is called Suzuki reaction. Right? Just a moment, I will show that. Not necessary, just listen and leave it. Observe that reaction. I am taking palladium at 0 oxidation state. Palladium at 0 oxidation state. This L represents ligands. So I am taking chlorine. So either PDCl2 or PDCl4. Right? Alkyl halide. First formed as a ligand with palladium. Then ligand exchange with either sodium ethoxide or thallium hydroxide or silver oxide. Ligand exchange. If I take thallium hydroxide, OH will replace X. Right? If it is sodium ethoxide, O ethyl group, ethoxy group will replace X. Right? Then we are using one base boron compound that will go and replace that boron complex. That means that OH group is replaced by it. Then on reduction, PDCl2 is gone. There is bond between R and R. Right? We call it as coupling or not? Right? So if I do coupling in presence of palladium salts, we call it as Suzuki reaction. Right? Instead of coupling, if I add either CO or any other group, or alcohols are oxidized to aldehydes or anything, we call it as Walker's reaction. Is it clear? Walker's oxidation, this is Suzuki. In both cases, I will use palladium salt only. Right? This is not necessary for us. Right? So, Walker's process. Yes, sir.
The screen is still showing the old notes, not the one you were talking about.
No issue. Not necessary. Don't worry. Right? Regarding Walker's process, it is. Stop talking. CH2 double bond CH2, it is alkene with oxygen in presence of PdCl2 and copper chloride CuCl2 in presence of water. Now oxygen got added to N of the carbon. So alkene got oxidized to aldehyde or maybe keto group. So we call this as Walker's catalyst and we call this process as Walker's process. Now again, CH3, CH2, 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 CH double bond CH2 plus half O2. PdCl2 in presence of CuCl2, H2O. Now, in above case, whether I add oxygen on any carbon, it is same because symmetrical it is. Now it is unsymmetrical. One side it is CH2 group, another side carbon chain is there. Prefer to add oxygen always on more substituted carbon side. Means I need to add that oxygen over second carbon. So product will be aldehyde or ketone now. Ketone. In above case, whether you add oxygen on any side, you will get same product. So product will be CH3, CH2, 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 C double bond O, CH3. Ketone is the product. Next, oxo process. This oxo process we have studied in hydrogen and its compound chapter. How can I show this? Whether I can open here or not, let me check. Say this one. Alkenes with the CO and H2 in presence of cobalt carbonyl, metal carbonyls to form aldehydes. This in
Sir.
reaction forms alcohols. We call
So
this
screen is
process
not
as
visible, sir.
oxo process. The online screen is visible or not?
No, sir.
Not visible, sir.
Wait, I closed it. Huh? Now,
Yes, sir.
Now it's visible, sir.
now see this one. This is called oxo process. Alkene with carbon monoxide, hydrogen, cobalt metal carbonyls forms aldehyde, which on reduction forms alcohols. Formation of aldehydes. Up to this, we call that reaction as oxo process. Whereas by using Walker's process, we have studied that Walker's process in D and F block chapter. If you remember. How can I close this one? In D and F block, last topic. See this one? Walker's catalyst, PDCl2. Alkynes in presence of PDCl2 forms aldehydes. Just now we have seen the same, right? Instead of PDCl2, if you take nickel tetracyanide or tetracyanonickel complex, right? Then you will get cyclization product. 4 moles we have taken, na? So what you got? COT, cyclooctatetraene. You will get COT, cyclooctatetraene. Response, sir. Instead of nickel, if I use iron and red hot iron, then you will get trimerization. You will get benzene. Clear? Same acetylene. If it is PDCl2, you got aldehyde. If it is iron as a catalyst on red hot iron, then you will get benzene. If it is a nickel tetracyanide, you will get cyclooctatetraene. Clear? Now, instead of alkyne, we have taken alkene. Same reaction. You will get aldehyde. Response, sir. No. Oxo process. What we'll do in oxo process? Alkenes with carbon monoxide and H2. What we got as water gas? Response, sir. And catalyst must be. In this complex, number of CO molecules are present as bridged ligands. Old JEE advanced question. In CO2, CO8, how many carbon monoxides act as bridged ligands? 2. Cobalt, metal, cobalt. There will be metal bond between cobalt and cobalt, right? Sir. Sir. పర్లేదు చెప్పండి. ఒక మెయిల్ వచ్చిందిగా 20 ఫౌండర్స్ డే ఈ మంత్ 22 గా ఇంకా ఏం రాలా మరి. అవును, జనరల్గా చేస్తాము, ఏం లేదు, ఫౌండర్ లేడు కదా. సరే, ఓకే సార్. Right? So two COs acts as bridge ligands. Remaining three over each other, there will be one metal bond. This is CO to CO8. Now product will be CH3 CHO. We also call it as hydroformylation of olefins. Correct or not? Alkenes are called as olefins. We are adding H2 as well as CO. That's why it is called hydroformylation of olefins. We also got as Abzo process. Any questions are in this? Next. So we are done with preparation of aldehydes or ketones from hydrocarbons. Next one, from carboxylic acids. Preparation of aldehydes and ketones from carboxylic acids. In which first one? Dry distillation of calcium or barium salts of carboxylic acids. Distillation of, stop talking. So if you take calcium acetate, I am taking R, O, CO. Better I will take this in this way. R, CO, O minus. R, CO, O minus. Ca plus 2. Is it calcium salt or not? Right? I am mixing this with another mole of calcium salt. Ca plus 2, O minus, CO. Now I am writing R prime. What is the meaning of this man? Both are two different calcium salts, correct? Huh? Both are two different calcium salts. Right? If it is formate, this is acetate. This is R, that is R prime. Right? Now remove CaCO3. How you will remove CaCO3 means, here I am taking Ca plus 2. From here COO minus. From here O minus. Why it is coming in this way? Okay. CO minus, Ca plus 2, O minus. Means CaCO3 is gone. So I will remove like this. Will you understand if I write like this? COO minus, Ca plus 2, O minus. Right? Now, second CaCO3 I have to remove from the other side. Here COO minus is gone now in this. Next, O minus is gone. So I am writing that in this way. Here O minus, here Ca plus 2, here COO minus. Now what is left? If from here CaCO3 is gone, then what is left? RCO R prime. In the above case, again same RCO R prime. So product will be 2 moles of CaCO3 is gone, plus you will get a 2 moles of RCO R prime. You got ketone. But what my intention is, if you take unsymmetrical acids, both are not same, both are different, then CaCO3 is lost, by combining both acids. If both are same, you will get the same type of product. You will get R, both sides. Is it clear? Any questions, sir, in this? Respond. Online. Any questions in this?
No, sir.
No, sir.
Now I am taking one more example, sir.
Sir,
Ketone. Yes, sir.
sir, this is preparation of ketone, sir. We are writing it under aldehyde,
Hey,
sir.
chapter name is aldehydes and ketones, man. Now what you will get? This on heating. Now will you get aldehyde or not? And
Yes,
now
sir.
remove CaCO3. CO3, CaCO3, it is gone. What do you get? Formaldehyde. Correct? Huh? Say something.
Yes, sir.
Yes, sir.
If I am taking HCO O minus Ca plus 2, here also I am writing HCO O minus plus now, sir. Now you get aldehyde or ketone? Yes. If I try to remove within the molecule, what you will get? If I try to remove CaCO3 within the molecule, in first case you will get aldehyde, but in second case you will get ketone. I will get two types of products. But here what I will get now? Actually CaCO3 should be removed from two molecules. So what should be the product? 2 moles of acetaldehyde. Will you understand now? Within the molecule, if you try to remove, you will get byproducts. Byproducts will be minor, this will be major. Any questions? Respond. In addition to that, you will get byproducts also. You can get these as the byproducts or not. Within the molecule, if CaCO3 is gone, you will get acetone. Within the molecule, CaCO3 is gone, you will get formaldehyde. So formaldehyde and acetone are the byproducts of it. That's why when you are doing distillation of mixed, you will get lower yield. Next, by heating carboxylic acids with manganese oxide. Second reaction. So 2 moles of carboxylic acid when heated with MnO, remove carbon dioxide. If I remove CO2, what you will get? H2O and CO2. Remove H2O, CO2. I'm writing RCOOH. Again RCOOH. I'm removing H2O and I'm removing CO2. Then what is left? RCOR. So you will get ketone. One specialty about MnO2 is this is MnO. Manganese is in +2 state. If I take MnO2, allylic alcohols will be oxidized, right, without disturbing others. Example. CH3COOH, 2 moles when heated with MnO2. MnO on heating. Product will be acetone. Last 2 benches. You are not studying on the top, you are making disturbance also. Next heading, sir. Methods of preparation of aldehydes only. Till now, whatever the methods we have seen, we can prepare aldehyde as well as ketone. Both are possible. Now, reactions in which only aldehydes are produced. So, methods of preparation of aldehydes only, which we will see in next class. I am posting the notes, sir, in your channel. Vitamins and proteins in biomolecules, so hormones part that I have not yet written. On the day I have shown, I will write and I will post. Okay, before completion of this chapter, I will do it.
Sir,
Yes, sir.
notes we will receive in Teams or in WhatsApp group, sir.
In WhatsApp group only, man. Right, once tell this attendance, man. Any of them present? Akshay Krishna, Abhishek Priyan, Charudishna, Duray Aditya, Ishanmayi, Gayatri, Hariharan, Harshada.
Present.
Hariharan
Yes,
present.
sir.
Harshada present. Joy Rignesh, Medarshini,
Present, sir.
Ajay Khanna, Nilesh, Jai Krish, Abhinav,
Present, sir.
Deshna, Sachin, Sachin and Deshna present. Okay. Sektivel Pandi, Saravana Perumal,
Present, sir.
Sarvesh, Saravana Perumal. Saravana Perumal, Sektivel Pandi.
Present, sir.
Sektivel Pandi. Saravana Perumal,
Present.
present. Sarvesh Kumar, Satyaseelan, Gautaman, Sri Darshan Jaykumar, Ilan Kumar, Vishandi, Sudanvel Alladi, Sujanar.
Present, sir.
Who? Vishandi, okay. Sweta, Tarun Krish, Pratiksha, Velavan, Vignesh Raja,
Sir,
Vishwajit.
Velavan online, sir.
Velavan present, okay.
Sir.
That's all, na?